Okay, so now we're going to take a look at some quantitative descriptions of aqueous solutions. And the first thing we're going to be taking a look at in this section is something known as the concentration of solutions. So generally, when we talk about concentration of a solution, what we usually mean here is a quantitative measure of the amount of solute in a solution relative to the amount of solvent or solution. So it gives us an idea of how much of that solute we have in a given, and typically the amount is going to be a volume that we're dealing with. Okay, so it's a relative, um, or it's a ratio, in other words. Now we're going to see several different concentration units. So there are lots of different units that we will encounter. Probably the most common and widely used concentration unit that we're going to see in chemistry is something called molarity, which is abbreviated big M. And this is also referred to as the molar concentration. And it is critical that we know what this means because we're going to see this, and you've actually already seen this in the laboratory. Whenever you use any solution, there's usually not just the name of the chemical, but also a number that precedes it that tells you the concentration of that particular solution. So molarity, or big M, which is the molar concentration, is defined as a number of moles of solute per liter of solution, right? So we can represent that as molarity, big M, is moles over liters. And that's critical. So again, moles of solute over liters of solution. Remember, solution is the combination of the solute plus the solvent. So we can rearrange this equation if we wanted to. So molarity here, we can solve for any of these other two variables. So we can say moles, for example, if we want to calculate the number of moles in a solution, we can take the molarity and we times it by the liters. Okay, remember now molarity is moles over liters. If we times that by liters, guess what? Liters cancel. We end up with moles. We can also rearrange this equation and we can solve it for liters or for volume. So we can say liters then would be equal to moles divided by molarity. And if we expand that out, moles divided by molarity is the same as moles times molarity over 1. That's the inverse of molarity. So we'd have liters on top, moles on the bottom, moles cancel out. We end up with liters. So this relationship, we can manipulate it however we want to solve for any of the other two variables, depending on what it is that we wanted to find. Now, a couple terms that we will see when we refer to the concentrations of solutions, we will see the terms concentrated versus dilute. Solutions. Okay, and the difference there is just relative. Okay, so concentrated solution has a higher concentration. We'll abbreviate concentration as CONC, and a diluted solution has a lower concentration. Okay, so for example, if I compare two solutions, a 0.5 molar NaCl versus a 2.0 molar NaCl. Okay, what does these actually mean? Well, it's important that we know how to first of all represent these. So 0.5 molar NaCl means that I have 0.5 moles of sodium chloride for every liter of solution, the sodium chloride solution. Okay, whereas a 2 molar NaCl means I have 2.0 moles of sodium chloride for every liter of solution. So obviously this one down here is more concentrated because there's 4 times as much solute in the same amount of volume of solution. Whereas the one above, the 0.5 molar, we say this is more dilute. Expand this word out, more concentrated for the 2 molar, more dilute for the 0.5 molar. We can also say it's less concentrated. Okay, so a critical thing here to keep in mind is when you see this molar NaCl, this is what it means, all right? And that's important because it allows us now to relate 2 units, moles to liters, and we can use those with that relationship to solve, to calculate, to rearrange whatever it is that we needed or that we need to do. A shortcut that you will see from this point onwards to represent molar concentration is square brackets, right? So we saw square brackets way back in the electron configuration section. Now when we see it with reference to or with respect to solutions, the square brackets means concentration of whatever is in the square bracket. So for instance, we can say square brackets NaCl equals 0.5 molar, right? This means the concentration of NaCl is 0.5 molar, 0.5 moles per liter. And we're going to use this a lot from this point onwards. So we'll see it not just in the rest of this semester, but if you take General Chemistry 2 and any other chemistry classes, that square brackets always means concentration of. So now that we know what molarity means, let's take a look at how we can calculate the molarities of solutions. And again, all we need to do is to keep in mind what molarity is. Okay, so here we have an aqueous solution of glucose, determine the molarity of a 2 liter of a solution that contains 50 grams of glucose. That's part A. Let's take a look at that one first. All right, so we need molarity of glucose. What does this actually mean? Well, we need moles of glucose per liter of solution, right? That's what molarity always means. Well, are we given any of these 2 things in the problem? Well, yes, we're actually given 2 liters of the solution, so that's going to go in the bottom. Are we given moles of the glucose? And the answer is no. We're given 50 grams of glucose. Can we convert grams? So we're given liters of the solution. That can just be substituted. We're given grams of glucose. Right, at this point, we should be able to convert that grams to moles of glucose. And then we can substitute this back into our relationship, right? So in order to convert from grams to moles, we use the molar mass, mm of glucose. We add that together, we get about 180. So we divide by the molar mass, we get the 0.277 moles. That gets substituted in here. We have our 2 liters of solution. That gets substituted in the denominator. So we divide those 2, and we end up with 0.139 molar solution. Okay, so if we're given, or if we have to calculate molarity, we need moles of the solute, we need liters of the solution, we divide them, that gives us the molarity. If in other cases we need to determine the volume of the solution that would contain 2.5 moles of glucose, well now for part B, right, we need liters, we need volume in liters. What we just calculated is the molarity, moles per liter, and we're also told now what volume will contain 0.250 moles. We have moles. Okay, so in order to get to liters, what we would do, right, is we can take our molarity. If we want to end up with liters, we can take this, we can flip it because that's a conversion factor. Liters over moles, and then we times it by the moles that were given, and we end up with our answer, right? So our concentration that we calculated was what, 0.139 molar. Okay, so this 0.139 molar, we can manipulate that as however we want to. That again, that means 0.139 moles per liter. We can use that as it is. We can flip it. We can say for every 1 liter on top, there's 0.139 moles on the bottom, right? And that's what we want to use here. Flip that, we have 1 liter on top, 0.139 moles on the bottom. That's my concentration that I just manipulate as a conversion factor. Now I'm told that we have 0.250 moles. Multiply that by the 0.250. Moles cancel out. We end up with liters as our unit. What we end up doing here, right, is dividing the moles by the concentration, which is the same thing that we did here. We end up with 1.80 liters. So we can use the concentration, the molarity, we can calculate it, moles over liters, but we can also use that relationship, flip it, manipulate it, turn it upside down, whatever we need to do to it to use it to solve any other problem that we're posed with.